important question. Of course, a PYQ which has appeared in JEE examination a few years back. And the question is related to molality when the density of a solution is given. So we need to understand or rather derive a relation between molality when the density of a solution is given. Please note, molarity is represented by capital M and molality is represented by a small letter m of a solution. So let us derive a relation between molarity and molality of a solution when its density is given. Now, for any derivation, it becomes very simple for us to assume hypothetical letters representing certain quantities. Mass of given solute be represented by W grams, volume of the solution by V milliliter, molality as we know is the small letter m, molar mass of the solute, let it be represented by m dash, molarity is represented by capital letter M. Please note, small letter represents molality and capital letter represents molarity. Weight of the solvent be W dash grams. Therefore, molarity we can simply very easily calculate. We know that molarity is the number of moles of a solute dissolved per liter of the solution. Based upon this, we calculate the number of moles of the solute, that is weight upon the molecular weight deposit, which is dissolved in V milliliter of the solution. Therefore, in 1000 milliliter, we can calculate this way. And our results are that M is equal to W divided by M dash into V, and this multiplied by 1000. From this, we can, if need be, we can calculate V also, the volume. So this is a simple simplification, easy simplification rather. Now next we need to calculate the number of moles per 1000 grams of the solute, that is molality. And now it is given that W dash, we have assumed here that W dash grams of the solvent contains number of moles is equal to W upon M dash, that is weight upon molecular weight. Then 1000 grams of the solvent will contain, we have calculated this way, and that represents M. M is equal to W into 1000 divided by M dash into W dash. So from here we can calculate W dash. Okay, so we have derived using these assumptions the molarity and also the molality. And then we know that density is equal to mass upon volume. D represents density, M represents mass, and V represents volume. Of course, it is not that molality minded. It is with reference to density, M represents mass. And that's why it is written here that density is equal to mass upon volume. And what is the total mass of the solution? The total mass of the solution is represented by weight of the solute plus weight of the solvent. That gives the total mass of the solution. So W plus W dash is the total mass of the solution and V is the volume of the solution. This gives the density. And now we can recalculate the density. W plus W dash is equal to W. That is weight of the solution. Weight of the solution is equal to W plus W dash. That is the total weight of the solution. And W is the weight of the solute and W dash is the weight of the solvent. Now weight of the solvent we have calculated here. We can substitute the values here. This has to be put, W dash is equal to W into 1000 whole divided by M dash into M. We substitute it here. And this can also be represented on simplification, of course. You can take it out this way and you can simplify to get an expression which is marked here as 4. And further simplification makes it still easier, and you get that D is equal to, you take out these values here, W into 1000 upon M dash, and if you simplify, you get W dash upon 1000 plus 1 upon M within the bracket, and whole divided by W by M dash into 1000 divided by M. Now, it's very simple, as we find that there are certain cancellations. 1000 is cancelled, numerator and denominator, because the same way number or values appear on the numerator and denominator, they get cancelled out. And finally, you can further simplify, you get 1 upon M is equal to D upon M minus M dash upon 1000. Well, this is our final expression for finding out the density, molarity, or even molality when the other values are given. Now let us move to the question. And the question is very simple, appeared a few years back in JEE. And the question is, dissolving 120 grams of urea, NH2CO, NH2 is urea. The molecular weight is given 60 in 1000 grams of water, gave a solution of density is also given 1.15 grams per milliliter. Molarity of the solution is okay. And a number of options are given. 4 options are there. We have to find out the correct option. Undoubtedly, now we can use that equation or the derivation which we have derived a little earlier. Let us calculate. Use the relation between density, molarity, and molality as we have derived earlier, which was a must for us. Simply going through the shortcuts would not be very much helpful to us. Therefore, it's very necessary that we should derive, we should know the derivation, we should know how we have arrived at this expression. Then we can calculate, putting up the values here as given. It is the molality is given as 120 grams per 1000 grams. 120 upon 60 is the molecular weight, that is 2m, and molecular weight of urea is 60. So put all these values, and finally on simplification you get the molarity, capital M, as 2.053. Well, these calculations are very simple and need not, they don't need much explanation. Please go through it and get the answer. The correct answer is option C here, and therefore option C is the correct answer. All other answers are not applicable over here and are incorrect. Okay, thank you. I suppose you must have got how to derive a relation between molarity when the density of a solution is given. And based upon this relation, a number of questions have appeared during earlier years in different competitive examinations. Thank you. Please don't forget to subscribe. Thank you very much.